In southern China lies Guangxi Province, an area with enormous potential as a trade hub. Bordering Vietnam and facing the South China Sea, Guangxi's location is strategically ideal. The Vietnamese capital, Hanoi, is just a short distance from the border, and Guangxi itself has a significant coastline. One would think this setup makes trade seamless. But in reality, the province's difficult terrain has long hampered transportation and logistics. Recognizing the challenge, China has launched a mega-project unlike anything the country has attempted in over 700 years, the construction of the 83-mile-long Pinglu Canal. This colossal waterway will connect inland Guangxi directly to the sea, essentially allowing cargo ships to travel over land. At full scale, the project involves over 900 workers pouring up to 353,000 cubic feet of concrete per hour during certain stages. While that may not sound earth-shattering in today's world of high-tech construction, the raw volume of material being moved, 12 billion cubic feet of earth and rock, is staggering. By cost alone, the Pinglu Canal ranks among China's most ambitious modern projects. With an estimated price tag of $10 billion, it joins the ranks of iconic national undertakings, even in an era defined by constant megaprojects. Guangxi seems perfectly situated for maritime trade, especially since its capital, Nanning, lies just 93 miles from major coastal ports like Fangchenggang, Qinzhou, and Beihai. But that closeness is misleading. On a map, the province appears tightly connected to the sea. On the ground, however, it's a very different story. Roughly two-thirds of Guangxi is covered in rugged mountainous terrain, interspersed with valleys, marshes, and countless rivers and lakes. This complex geography makes infrastructure development an uphill battle, literally. Still, China has pushed through, building over 38,000 miles of land routes throughout the province. It's an impressive feat, but not without drawbacks. These winding roads follow the natural contours of the land, leading to frequent accidents, congestion, and high maintenance costs. To supplement the roadways, a network of rail lines was developed, including the Xiangwei Main Line and branches to Kunming and Qinzhou. Yet, even with these additions, transport capacity continues to fall short. Compounding the issue is the difficulty of maintaining these routes in mountainous areas, where repairs are harder to perform and delays are more frequent. In search of a more reliable alternative, China turned to the province's abundant water resources. Guangxi holds roughly 49.6 trillion gallons of surface water, about 7.1% of the country's total. Several rivers within the province allow for inland cargo shipping. However, the current water routes are far from efficient. To ship goods from inland Guangxi to the Bibu Gulf, vessels must travel a long and winding path along the Xijiang River and then into the Pearl River Delta. Only after this lengthy detour can cargo be transferred to large ocean freighters. What should be a 93-mile trip turns into a 310-mile journey, costing time and money, and lots of both. Even so, Guangxi remains a major export powerhouse, especially in trade with ASEAN, the Association of Southeast Asian Nations. This includes Vietnam, Malaysia, Indonesia, the Philippines, and others. In 2023, Guangxi's trade with ASEAN reached 339.4 billion yuan, around $47.8 billion. That number climbed to nearly 400 billion yuan, $55.6 billion, in 2024, and the growth shows no sign of slowing. Guangxi's strategic position has also made a focal point in China's new International Land-Sea Trade Corridor, NAILSTC. This initiative aims to connect western inland provinces with Southeast Asia. In this effort, Guangxi serves as the final stop for outbound goods. But even with its geographical importance, Guangxi's outdated trade routes create bottlenecks. Imagine goods traveling efficiently from neighboring Guizhou, only to get bogged down in Guangxi's rivers for hundreds of miles. Clearly, something had to change. Enter the Pinglu Canal. Construction officially began in 2022, aiming to directly connect the Shijin Reservoir on the Yu River to the lower section of the Qin River. At 83 miles long, the canal is designed to create a straight path from Nanning to the Bibu Gulf. It's an engineering solution that promises to eliminate the most time-consuming leg of the journey, while costing significantly less than more circuitous infrastructure upgrades. Though with a $10 billion budget, it's far from inexpensive. For comparison, the iconic Three Gorges Dam, once the world's largest infrastructure project, was so immense it slightly slowed Earth's rotation. Yet, the Pinglu Canal will involve excavating 3 times more soil an estimated 12 billion cubic feet. The canal's depth, ranging from 20.6 to 21.3 feet, and its 81-mile stretch across varied terrain make this a monumental task. To manage the scale, the project was divided into 5 sections, each requiring its own specialized techniques. In areas with soft soil, massive hydraulic dredgers and excavators dig up to 9 million cubic feet per shift. In rocky terrain, teams use dynamite and hydraulic hammers to blast and break up stone. Frequent rain in Guangxi adds another layer of complexity. Dig a hole here, and it quickly becomes a swamp. But China planned for this. Excavated areas are equipped with drainage systems and temporary dams, while perforated pipes remove hundreds of thousands of gallons of water per hour. This keeps the worksite dry, even in torrential downpours, and allows the project to stay on schedule. Even the trucks are part of the high-tech approach. Fitted with load sensors and real-time data transmitters, they feed information to a centralized command center. That center is part of a fully integrated digital platform used to monitor progress, coordinate logistics, and prevent delays. And yes, artificial intelligence is involved. DeepSeek, one of China's cutting-edge AI systems, is being used to optimize material transport and track construction milestones. But all the tech in the world won't help without raw materials, especially concrete. Project insiders estimate that hundreds of millions of cubic feet will be needed before the canal is complete. As of now, the operation employs about 20,000 workers and runs 4,800 heavy-duty machines, along with countless smaller units. It's one of the largest construction efforts in modern China. But one element stands out even among all this: the Mao Lock. Unlike a simple trench, the Mao Lock involves excavating a pit over 216 feet deep. By May 2024, more than 1.2 billion cubic feet of material had been removed. Dedicated smart concrete factories were built nearby, equipped with digital systems and temperature-controlled mixing towers. 2 production lines were fitted with pre-cooling units to maintain optimal pouring conditions. To deliver the concrete, 185 specialized trucks work in shifts, supported by 30 backup vehicles and 26 belt placer units, plus 9 in reserve. It's a continuous, streamlined operation. Once completed, the Mao Lock will be one of 3 main lock systems and will serve as the most important. The design is fairly standard. A ship enters, water fills, or drains the chamber to match the next elevation level, and the gates open to release the vessel. But the Mao Lock includes a record-breaking twist. It will be the world's largest internal water-conserving lock. Rather than draining all the water, it stores some inside reservoirs for reuse, cutting water consumption by 60%. As of spring 2025, 87.6% of the earthworks have been completed. In 2026, work will shift to hydraulic system installation. The Pinglu Canal, including all locks, is scheduled to become operational later that year. When it does, the benefits will be vast. The canal will create a direct trade corridor from Nanning to the Bibu Gulf, shaving off 348 miles from the current route and saving an estimated 52 billion yuan, $7.2 billion, in shipping costs annually. More importantly, it will modernize Guangxi's inland transport network, allowing 5,000-ton vessels to navigate directly to sea year-round. This fits perfectly with China's broader trade strategies and will likely draw investment in logistics, manufacturing, and port services. By 2030, dozens of industrial parks are expected to emerge along the canal. Cargo volumes at ports are projected to rise by 25 to 30% compared to 2025. Nationally, the Pinglu Canal will reduce reliance on southern ports like Guangzhou and Shenzhen, giving China more control over its maritime trade flow. But all this development raises a critical question. What about the environment? Surprisingly, the project has taken extensive steps to minimize ecological disruption. The motto behind the construction is clear: free-flowing rivers, clean water, and thriving ecosystems. Environmental compliance is baked into every stage. A full year of monitoring water, air, and soil quality is built into the plan. The canal also incorporates wildlife conservation. For aquatic life, especially migratory fish species like eels and perch, special passageways are being constructed, over 1,500 feet long, featuring vertical slots and angled paths. A tracking system will monitor fish migration and allow engineers to adjust the design if needed. Land animals weren't forgotten. Near Mao, 2 65-foot wide overpasses have been built for wildcats, squirrels, hares, and wild boars. These crossings are surrounded by native shrubs and trees to provide food and shelter. Marine life has also been protected. Before construction began, over 20,000 oysters were relocated to safe zones, with a survival rate over 90%. A separate oyster farming initiative is underway to repopulate the region after the project is complete. Mangroves, too, are being preserved. Nearly 10,000 plants were transplanted to protected zones, while 275,000 new trees have been planted. Non-woven screens and absorbent barriers help prevent silt from choking the roots. Finally, 36 natural riverbends and lakes are being preserved as microecosystems. Monitoring stations on land, in the canal, and at the marine entrance will track the health of these environments with sensors measuring temperature, salinity, oxygen levels, and more. Even the construction itself is eco-friendly. Low-emission machines use biodegradable lubricants. Cables and pipelines are laid through green corridors to avoid deforestation. Temporary roads are made from recycled crushed stone to reduce erosion. In the end, the Pinglu Canal stands as a rare example of mega-engineering that tries to work with nature, not against it. It's not just a trade corridor. It's a vision of how infrastructure can evolve to meet economic needs without sacrificing the environment. Think the Arctic is just a frozen wasteland. Think again. Northern Russia, long known for its icy extremes, is now at the center of one of the world's most ambitious infrastructure expansions. Russia and China have teamed up to transform the Arctic into a major trade corridor through the development of the Northern Sea Route, or NSR, and they're not holding back. Massive dredging operations are underway, pulling millions of tons of soil from the seafloor. A major terminal is under construction that will one day handle 100 million tons of oil, one of the world's most vital resources. This isn't some small-scale effort. It's part of a $100 billion mega-project that includes everything from power stations to newly built villages, all designed to support this Arctic trade route. Connectivity isn't a problem either. Russia is laying down thousands of miles of fiber-optic cable across the tundra. In short, the Arctic may be cold, but it's heating up fast, economically and geopolitically. But this surge in activity isn't going unnoticed. The United States and Canada aren't exactly celebrating this shift in the global trade landscape. And for good reason. The NSR could challenge one of the world's most important trade passages, the Suez Canal. Let's zoom out for context. The Northern Sea Route isn't new. It's been in use since the 1930s. But until recently, it played only a minor role in international shipping. In 2022, just over 34 million tons of cargo passed through the NSR. In 2023, that figure crept up to 36.2 million tons, a record, yes, but still tiny compared to its rival. That same year, the Suez Canal moved roughly 1.5 billion tons of cargo, even while facing serious disruptions. The disparity is staggering. So, what's holding the NSR back? Ice. Lots of it. Despite recent warming trends, the Arctic remains frozen for much of the year. In many stretches, the NSR is navigable for only about 2 months annually without the help of icebreakers. The Suez Canal, by contrast, is ice-free year-round. Russia, however, has a solution: its fleet of powerful icebreakers. As of early 2025, Russia operated 34 diesel-electric icebreakers and 8 nuclear ones, more than any other nation. These icebreakers regularly guide cargo ships along the Arctic's treacherous waters. In 2023 alone, Russia's nuclear fleet completed more than 730 escort missions. One notable operation involved the rescue of a bulk carrier named Gingo, which had capsized while carrying over 160,000 tons of iron ore. It took 13 days, but the mission succeeded, proving the fleet's crucial role. Still, even with this support, the NSR can't yet match the cargo volumes of the Suez Canal. The infrastructure and natural limitations are just too great for now. But that may be changing. Climate change is shrinking the Arctic ice cap, opening up longer windows for navigation. Researchers say this trend could eventually reduce the need for constant icebreaker assistance, lowering operational costs and making the route more attractive. And here's the kicker: the NSR is significantly shorter for certain routes. Take Tokyo to Hamburg, for example. The NSR cuts that trip to about 8,000 miles compared to 12,400 miles through the Suez Canal. That's a big deal. Meanwhile, trouble is brewing for the Suez Canal. The Red Sea region, which it feeds into, has become increasingly dangerous. Pirate attacks, missile strikes, and political unrest have all disrupted shipping. In 2024, just over 13,000 vessels passed through the canal, a 50% drop from the previous year's 26,000. That kind of uncertainty is pushing companies to consider alternatives, and the NSR is looking more viable by the day. Let's dive into one key hub of the NSR, the Bay of Ob, home to the Sabeta port. It's central to the Yamal LNG project, a joint venture between Russia and Chinese investors. Liquefied natural gas produced here is shipped directly via the NSR to international markets. By 2019, Sabeta was already moving nearly 20 million tons of cargo annually. But Russia had bigger plans. The largest dredging effort in Russian history was launched to deepen and expand the Bay of Ob's sea channel. In 2020, a multinational fleet of dredgers and over 1,000 workers removed more than 1.1 billion cubic feet of soil from the seabed in just 79 days. The aim? To make the channel accessible for Yamal-Max-class LNG tankers, giants that measure nearly 1,000 feet long and carry up to 80,000 tons of cargo. By 2030, project leaders expect the channel to accommodate up to 9 such vessels per day, drastically increasing throughput. Now head east to Dixon, Russia's northernmost settlement. Just 25 miles away, a massive oil terminal is rising, Bukhta Sever. Construction began in 2021 with the delivery of 20,000 tons of cargo and materials by ice-class ships. Phase 1 included docks, storage areas, workshops, and coastal reinforcements. As of early 2025, work is well into its next phase, which includes 2 oil loading piers and the backbone infrastructure of the Sever terminal. Once completed, it will feature 102 oil storage tanks and an annual capacity of 100 million tons. That would make it Russia's largest oil terminal right in the Arctic. Feeding this giant facility is another huge project, Vostok Oil. With a $100 billion price tag, it's developing Arctic oil fields that will feed directly into Sever. A 248-mile pipeline is planned to move the oil, supported by 13 new power plants and over 4,300 miles of transmission lines. Plans also call for 15 new towns and 2 airstrips to support the operations. Will all of it be built? That remains to be seen. But even if only the core infrastructure is completed, including the port and pipeline, it will mark a massive leap forward for the NSR. Then there's the Polar Express, a 7,800-mile-long underwater fiber-optic cable stretching from Murmansk to Vladivostok. Russia is already producing the necessary cable at a new facility in Murmansk. The goal is clear, to ensure that every inch of this Arctic corridor is connected and operational. International players are taking note. The United Arab Emirates, through its global port operator DP World, signed a 2021 deal with Russia's Rosatom to co-develop the NSR. Their efforts include modernizing the port of Vladivostok and enhancing Murmansk, both key entry and exit points along the route. China, meanwhile, is deeply involved. It launched the Polar Silk Road in 2017, the Arctic branch of its Belt and Road Initiative. Through this, China has poured money into Arctic ports like Sabeta, Arkhangelsk, and others. In Arkhangelsk, it's backing a new terminal for large vessels, along with a 500-mile railway linking the port to inland Russia, further integrating the NSR with China's global trade network. All these projects are pushing toward an ambitious goal: 220 million tons of cargo annually along the NSR by 2035. That's over 6 times the 2023 total of 36 million tons. Is it achievable? Maybe, but it'll require everything to go right. Reduced ice, lower costs, better infrastructure. All of that is working in Russia's favor. A typical journey from China to Europe via the NSR could take just 19 days, compared to 48 days through the southern route. Plus, there are no pirates in the Arctic and no missile strikes to worry about. Still, the competition isn't sitting idle. The US and Canada have access to their own Arctic path, the Northwest Passage. But they're far behind in ice-breaking capabilities. The US hasn't designed a new heavy icebreaker since the 1970s. Its only operational one, the aging Polar Star, is nearly 50 years old. A new vessel is under development, but the project is years behind schedule and 60% over budget. Canada is faring slightly better, with 9 icebreakers in service and 2 heavy ones under construction. But neither country currently has the capacity to challenge Russia's Arctic dominance. This imbalance is raising alarms in Washington. China's Arctic ambitions are also on the radar. It operates research stations in Norway and Iceland and has made moves to gain influence in Greenland, offers that were ultimately blocked with help from Denmark. So where is all this heading? The NSR is no longer just a Russian fantasy. It's shaping up to be a genuine alternative to traditional trade routes and possibly a serious rival to the Suez Canal. But its future depends not just on engineering and logistics, but also on geopolitics. And in the Arctic, as in the rest of the world, politics can shift as fast as the ice.